Hello, Professor Bialis here. In this video we are going to be talking about the last section in Chapter 1, Section 1.8, which is talking about the properties of real numbers. Now these properties are things that you should have seen in the past, and these are actions that we know will work and we've used them time and time again, but we're going to put names to it, so if we ever need to explain what we're doing, we'll be able to do so. Now, let's get started. Okay, this first one that we're going to talk about is called a commutative property. Now, a lot of times we just say commutative property and that's it, but there's a little bit more to it, a little bit more detail that we need to make sure we attach to it. So, when we say commutative property, we need to specify what operation that commutative property is actually being utilized under. What I mean by that is we would say commutative property of addition or commutative property of multiplication. Okay? Now, the other two operations, subtraction and division, those are not commutative. Now, first of all, what does it mean to be commutative? Commutative means that the order does not matter when we do the calculation. So when we deal with commutative property of addition, that tells us that if we were adding, 3 plus 2, that's the same thing as 2 plus 3. The order in which we add those does not matter. Same thing with multiplication. If we had 3 times 2, that would be the same as 2 times 3. So again, whether it's addition or multiplication, what commutative property allows us to do, or what it tells us, is that order does not matter. Okay? Now, in terms of subtraction and division, we can get around the issue a little bit if we know how to manipulate the problems. For instance, if we had, let's say, 2 minus 3, is that the same as 3 minus 2? Okay, well, if we calculate that out, we can clearly see, no, that wouldn't be the same. However, they're pretty darn close. 2 minus 3 is -1, 3 minus 2 is +1. Remember, with subtraction, we can rewrite that problem, 2 minus 3, as 2 plus -3. Now what did I just do? I changed that to an addition problem, which is commutative. So what I can do then is make that switch like so. Okay? So subtraction at its core is not commutative. However, if we know how to manipulate these things a little bit, we can turn it into something that is commutative. So be aware of that as we're going through expressions and equations and things like that. Same thing would be true about multiplication and its counterpart, division. If I have 6 divided by 3, that is not the same, so okay, that's not equal. This is not the same as 3 divided by 6. Okay? This is 2, this is a 1/2. What we could do, though, instead of saying 6 divided by 3, we could rewrite that as 6 times a 1/3. Again, division is not commutative. I can't flip the order. But if I rewrite that division as multiplication, and in this case multiplying by the reciprocal, then I have more freedom to manipulate that problem. Okay, and again, when we get into equation solving, anything that we can do will be helpful. Okay, so that is the commutative property of addition, illustrated here, or of multiplication, which is illustrated here. Okay, a lot of times what we try to do when we're presenting a property like this is a very concrete example, which is perfectly fine to illustrate the idea. But what we try to do is keep this a little bit more general. So if we really want to show it, we would show it this way. A plus B is equal to B plus A. If you ever read a math book or a website and they show you something like this, they're just keeping it open to any number in existence. If you have two different numbers, okay, or they could be the same, if you flip the order, it's not going to matter. Whether it's 2 plus 3 or 1.7 plus 8/3, something like that, it's not going to matter. Same thing with this multiplication. Typically, you would illustrate that like so. Okay? That is the commutative property. Next, let's talk about the associative property. The same two subgroups are going to be in there. Associative property of addition and associative property of multiplication. Okay? Now, what is associative property telling you that you can change a little bit? Commutative property was that the order does not matter. Think of commuting to and from school. The spot that you're in doesn't really matter. Associative property is talking about association. Who do you associate with? Who's your group of friends, so to speak? So associative property, in just kind of general terms, is grouping. Does not matter. Okay? Now, in general, grouping matters a lot, but in these situations, it doesn't. So, what does that look like? Associative property of addition would be when you have, for instance, 3 things, could be more, okay? But just using 3 for illustrative purposes. So, what we're going to do is we're going to take this A plus B and group those first, okay? Now, that would be the same thing as if I took the same 3 terms being added and I grouped these, okay? Now, at first glance, it doesn't seem like I did much of a difference there. However, if you're doing order of operations, here you would be adding these first, then tacking that C on, versus adding these first, then tacking the A on. That's a very different process that you're going through, but the result will be the same. Same thing occurs with multiplication. If I take, let's say, these 3 things and I'm multiplying them, if I group these 2 or these 2, the result will be unchanged. It will be exactly the same. Okay? Now, what I see a lot of people do is they say whenever there's parentheses, associative properties being used, not necessarily. Always look for what change is happening. If the order changes, you're talking about commutative. If the grouping changes, you were talking about the associative property. Okay? So, let's do one more and then we'll do a couple examples. Okay, this next one is called the distributive property. Now, usually that's what we say, distributive property. However, the full name is distributive property of multiplication over addition. Okay? The general layout of what this looks like is when we have something like this. Okay, now again, just at first glance, it kind of looks like the associative property. However, if this was the associative property, all of these operations would have to be the same. Okay, they either both have to be multiplication or both have to be addition. This is now mixing the two. Now, what the distributive property of multiplication over addition tells us is that we would have to take this A and distribute it or apply it to each of those pieces within the parentheses. So it would turn into A times B plus A times C separately. Okay? That basically unlocks that group. When we get into equation solving, we're going to be doing that a lot. Okay? More concrete example, would be something like this. Let's say we have 2 times x plus 5. What I would do is I would distribute that 2 over. 2 times x we would just write as 2x, and then 2 times 5 is 10. Okay, and then that would be a new expression that we can work with. An equivalent expression, but new expression nonetheless. Okay, so let's look at some examples of what kind of questions they're going to ask you. And then there are a couple other properties we're going to finish up with afterwards. So I want you to name the property used. Okay, and let's start out with this. Which of the properties that we've talked about so far is being illustrated with this example? Now, if we look at it, again, you see the parentheses. A lot of people say, well, it's associative property because the parentheses are there. But the parentheses, the grouping, does not change. 3 is with 5, 3 is still with 5. The order within that changed. So if order is being changed, we're talking about the commutative property. And don't forget, we were flipping over addition. So commutative property of addition. Okay, so be very careful of what the change actually is. Next, how about this? Okay. What property or properties are being used in this one? Okay. We had commutative property of addition multiplication. We had associative addition multiplication. And then we had that distributive. Distributive isn't really being utilized here because everything is multiplication and we're not laying out or breaking out of those parentheses. What we do have going on is 7 grouped with n and now 7 grouped with 8. So grouping has changed. Okay, so associative property is being used. However, the order is also being manipulated. 7n 8, 8 7n. Order changed and grouping changed. So both the commutative property of multiplication and the associative property of multiplication are being illustrated in that example. So it doesn't have to be one at a time. You could have, 3 or 4 different properties being utilized. So look at all the changes that are presented to you. Okay, and then one more. How about that? Okay. Now, you could say, well, there was grouping there, so that, then there's no grouping here, so it changed. But why did it change? It changed because we distributed, this is a minus sign here, just to be clear, we distributed that 3 onto the x and onto the 5. Normally we would write this as a 15, but just to show you what's going on, they typically leave it as 3 times 5. So this would be the distributive property. A lot of times it's pretty well accepted just to leave it as distributive property. Okay, so there you have the how many 5 main properties that we're going to be dealing with within this section. Now there's a couple other properties that I do want to show you that are very, very simple. We take them for granted because they are so simple, but I want you to know what they're called and what they look like on paper. So, and one other thing. It was distributive property of multiplication over addition, but some of you may be thinking, well, wait a minute, there's subtraction there. Remember, subtraction and addition go hand in hand because I could very easily change that to a plus -5. Okay, so when we say addition, typically subtraction is also being accepted within that because of this very easy switch. Same thing when we deal with the multiplication, as I was saying before. Division technically doesn't fall under that, but division can be adjusted into multiplication. So a lot of times when you have a multiplication property, division is also going to be accepted within that. Okay? So, now let's look at what's called the additive identity property. Okay? Additive simply means you're using addition. Identity means you're trying to keep things identical. You're getting the identical expression or term. And then we have a property. Now, the question I'm going to ask you is this. If I have 5 plus something equals 5, what would I be adding there? In this case, I would be adding a 0. If I have a negative 1/3 plus what gives me an identical negative 1/3, I'm adding a 0. If I have anything plus what gives me back that original, that would be a 0. This is your general additive identity property. All that's saying is what happens when you add a 0. It keeps it identical. It keeps it the same. Okay? Another phrase that I want you to take out of this is 0 is the additive identity. Okay, so if I ever ask you or someone asks you, what is the additive identity? 0. Okay? Next one. Let's go to the multiplicative identity property. Okay? Now, multiplicative identity is just the same idea, but with multiplication. So if I have a, let's say, 3 times what keeps it an identical 3. In this case, it's a little different, but it's just a 1. 1, that's it. If I have a square root of 7 times what keeps it a square root of 7? 1. Anything times 1 keeps it the same. And there is your multiplicative identity property. Another phrase you could take out of this is 1 is the multiplicative identity. Okay, so if I ever ask you what is the multiplicative identity? 1. That's it. Okay? Now, we are going to take these ideas and we are going to expand them to something a little different. Okay? So, this next one is called the additive inverse property. Okay, now an inverse is something that is going to be coming up again and again and again. It's a very, very important idea in mathematics. Okay, let's start with something concrete just to get the idea across. Additive inverse property. Any inverse will always be producing the identity. Okay, any inverse produces the identity. So if I'm going to go with addition and I take a 2, I am going to add the inverse to get the identity. Okay, remember the additive identity is that 0. So in this case, what am I adding to a 2 to get it to be a 0? That would be a negative 2. If I have a 3/4 plus what will give me the identity of 0? That would be the additive inverse, and that would be a negative 3/4. Anything plus its opposite will give you a 0. Okay? So again, we think of, okay, these are opposites, no big deal. but a more technical term for that would be the additive inverse. Okay, so opposites are additive inverses of each other. Okay, so if I had like a 2, its additive inverse is -2. But a -2 has an additive inverse of 2. So they are inverses of each other. Both of them combined will give you that 0. Okay, very similar idea with the multiplicative inverse. Okay, same idea in the sense that we are looking for the identity, in this case the multiplicative identity. So if I take 5, what do I multiply it by to get the identity of 1? Okay, and in this case we are going to be looking for a 1/5. If I take a 2/3, let's say a -2/3, and I want to multiply it by something to get a 1, I would multiply it by a -3/2. Okay, so anything times its multiplicative inverse would give you a 1, and that would simply be, in this case, 1/a. Another more simple term for that would be a reciprocal. Okay, so when I say multiplicative inverse, I'm talking about a reciprocal. Okay, so again, very simple ideas. We've done this a bunch of times. We've done this a bunch of times. We're just putting a name to it now. Nothing more than that. Okay, it's just to help us communicate what we're doing, as opposed to saying, I just take those numbers and I flip them to get a 1. Okay, well, I'm using a reciprocal or a multiplicative inverse to get the identity. Okay, that's a much more precise way of saying it, as opposed to I'm just doing something with these numbers. Okay. The other thing I want you to notice is, notice here, I didn't change the sign on these. Okay, I was keeping them, if they start positive, I end up positive. If they start negative, I end negative. So be careful with that little detail. Okay, let's go back to just a couple more quick examples of these, and then that'll be it. Okay, so again, I'm going to go back to those examples I had before where it said, name the property being illustrated. And how about this one? What property does that illustrate? Okay, now this can be a little tricky because you see that 0, so you're thinking additive, okay, but is it additive identity or additive inverse? They both utilize that 0, okay, except here we're actually adding with the 0 as opposed to getting the 0 at the end. So this would be the additive identity property. Okay, because we're using the 0 to get the identical 4 at the end. If this was like this, okay, here we're using that opposite, which is the additive inverse property. Okay, I personally am okay with these abbreviations, but if you have another instructor, double check with them to see if that's okay or if they want you to spell out the whole thing. Okay, how about this? Squeeze one more in there. How about okay? Now this one, again, you're doing multiplicative, obviously, but are we using the 1 or are we getting the 1? In this case, we're getting the 1 using that reciprocal. So this is going to be a multiplicative inverse property. Okay? Take your time with these. Don't be afraid to try something on your assignments. That's the whole point of the assignments, so you can try things out and see where you're making mistakes, what works, what doesn't, and all that good stuff. Okay, but it's so important that you guys are trying these out before you jump into the exam, and then trying to figure it out on your own. Okay, so as always, work hard. If you have any questions, let me know. I'll see you next time.